Hello everyone, in this video I'm going to show you how to read a battery and then I'm going to show you how to measure the health of a battery. So the batteries I have here are two, both from motorcycles. So we have one larger one and a smaller one here. Now what we can look at on the front of a battery is, first of all, we should always see the positive terminal and the negative terminal of the battery indicated. So that should always be indicated. If it's not painted on, you should see an imprint on the plastic casing of the battery. So we have a positive and a negative symbol here. So we know which terminal is which. Now, there's obviously the branding, the brand of the battery. This one is a Unibat. This one here is a Schnell battery. So that's just the branding. There's some basic information. But the information that we really want to look at is down here on this particular battery. It's down here on the bottom right hand side. So we can see that it states 12V8AH120CCA. So this information here is key information, which tells us about the specifics of this battery, what it's capable of doing. And then on the bottom left hand side we have some more information, and it says here that it's the charging method. So it has some more information on how to charge it. So we'll start here on the information on the bottom right hand side. So the 12V indicates that it's a 12 volt battery. Now, just because it says 12V doesn't mean that the voltage between the two terminals of the battery is necessarily 12 volts. Usually for any 12 volt battery, the voltage between the two terminals of the battery when they're brand new is usually between 12.6 and 13.1 volts. Now the 8AH, this indicates the capacity of the battery. So this is how much power or current the battery can supply. So how do we read 8AH? Well, the 8AH indicates that it is an 8 amp hour battery. So we'll just write that down. Usually you'll see it written like this. So 8AH. It's usually with a smaller h, okay? And that indicates that the battery has a capacity of 8 amp hours. So amps is the measure of current, the current flow. So we can ascertain some information from this 8 amp hours rating for this battery. Now, usually what you might actually see is it'll have something like this beside it. It might have 10 HR. Okay? Something like that might be beside it, and that indicates that the measurement was done. It's an 8 amp hour battery measuring at a 10-hour rate. So what is the 10-hour rate? Well, the 10-hour rate is a common measurement for starter batteries. Sometimes you might actually see, on some batteries it might say 8AH, and it'll have a 20H or a 20HR. That is a common measurement for deep cycle batteries. So this is for deep cycle batteries, and this is the measurement generally for starter batteries. Now these batteries that I have here are starter batteries. But they're also they're also actually deep cycle batteries. So what's the difference between a starter battery, or what does starter battery and what does deep cycle battery actually mean? Well, a starter battery is a battery whose main purpose is to supply power to the starter motor to get the engine running. And after the engine is running, it's only supplying power for a couple of seconds, and after that it should be recharged. So the motorcycle should be recharging the battery. Okay, so that's a starter battery. A deep cycle battery is a battery where it might not just start the engine, but it might actually be supplying power for a it might be expected to supply power for a protracted period of time without actually being recharged. So the power will be drained, and possibly to the point where the battery is dead. Now at that point you want to recharge the battery. So if you recharge the battery either by leaving the engine running or by sticking it on a charger, it should bring it back up to full capacity or full charge. And it should be able to go through that cycle of being discharged and recharged a number of times. So how do we read this 8 amp hours? Well, that essentially, the way we can kind of think about it in simple terms is that the battery will supply 8 amps for 1 hour. Or we can also read it as the battery could alternatively supply 1 amps for 8 hours. Okay, so that's in theory what the 8 amp hour capacity means. It means that it can continuously supply 8 amps of power or of current for 1 hour. So after 1 hour that battery will be gone dead in theory. And then it can also supply 1 amps for 8 hours alternatively. Now it could also, this is where the 8 or the 10 hour rating comes in. The way this battery was measured is for a 10 hour rate. So for a 10 hour rate it was able to supply 0.8 amps. For 10 hours. Okay, now these scenarios are obviously not very realistic. They're just to explain how you actually read this 8 amp hour capacity. Depending on what that current drain is going to be, that really determines how long that battery is going to last. So the next measurements that we can look at on this battery is the 120 CCA. So the 120 CCA, that indicates, so 120 CCA, that indicates the cold cranking amps. The cold cranking amps. So this is essentially a measure of what power this battery can output over a short period of time. To start a motorcycle engine, this battery needs to be able to supply a huge current to the starter motor to get that engine turning and get it started. It doesn't need to do it for more than a couple of seconds generally. Now that current can be very high, and we need a battery that can supply enough of that current. Now what this rating of 120 CCA indicates is that this battery can supply 120 amps of current to the starter motor in certain conditions. Now the cold cranking amps is, the conditions for cold cranking amps is generally, it indicates that it can do that at 18 degrees or minus 18 degrees Celsius for 30 seconds 30 seconds before the battery voltage goes below 7, I think is it about 7 volts, something like that. These numbers might not be exactly correct, they're approximate, okay? But that's what the cold cranking amps measurement is. Now obviously in reality, where I live, the temperature never goes down to minus 18 degrees Celsius. So the cold cranking amps is a measure of the battery's performance under extreme conditions. You shouldn't be cranking over your engine for 30 seconds straight. You just shouldn't be doing that. If you're doing that, there's something wrong with your engine or your starter motor or possibly even the battery. You shouldn't be cranking over for 30 seconds. You really shouldn't be going out on your motorcycle at a temperature of minus 18 degrees Celsius, and the 7 volts indicates that when you are cranking over the engine and you're supplying this current for a protracted period of time, the voltage will decrease over time. So as you draw current from the battery, the voltage will decrease over a matter of a couple of seconds, very quickly. But over 30 seconds, supplying 120 amps, it shouldn't go below 7 amps. That's what the cold cranking amps measurements or rating indicates. It's important when we want to determine the health of this battery, which I will talk about in a few minutes. Now, the other thing, let's put that to the side. The other thing that we want to look at on the battery is the charging method. So this is quite important, because if you take the battery out of the motorcycle over the winter, for example, or after it's been sitting in the shed for a couple of months or a couple of weeks and you want to take the battery out and charge it, you need to know what conditions you can charge that battery at. So the charging method indicates that the standard rate of charge is 0.8, the standard STD is 0.8A by 5 with a little middle line dash 10H. So what does that indicate? That indicates that we can charge the battery, the standard charge rate is at a rate of 0.8 amps. Standard charge rate, okay? So I'll just put standard charge rate. This is the preferred method of charging the battery. Charge it at a rate of 0.8 amps, okay? And you want to charge it for a period of between 5 and 10 hours. Okay, so if you charge it for 10 hours at 0.8 amps, you should end up with 8 amps of current, or let's say power or charge, built up in the battery for 10 hours. After 10 hours. Okay. And that corresponds with the 8AH, which is the battery capacity. So the 8 amp hours. So if we charge it for 10 hours at a rate of 0.8 amps, we should get it to full charge capacity, or 8 amps. Okay. And if we charge it at a rate of 0.8 amps, for 5 hours, then we should get half that, we should get 4 amps after 5 hours. Okay. Now, when would you charge it for 5 hours? Well, if the battery is half drained, you would generally charge it for 4 hours. If it's fully flat battery, you would charge it for 10 hours at that same rate. Okay, so that's what the charging, how you read the charging method. Now that is important because here is the battery charger that I actually use to charge this battery. Okay, so I only charged it the other day. We have our red lead, which goes in the positive terminal, black lead goes on the negative terminal. Plug it in, and I can select two different modes. I can select it for charging a car battery or a motorcycle battery. Now on this charger here, it says that it can charge at a rate of 2 amps. So for a motorcycle, it's going to charge it at a rate of 2 amps. So 2 amps is higher than the 0.8 amps. And that's important, because I kind of have to ask, well, is that too high an amperage to charge this battery at? Is that safe to charge it at 2 amps if the standard is 0.8 amps? Well, I can see here that it says underneath here on the battery, it says 4.0 A by 1H. So that's for a quick charge, right? So I'll move that out of the way. So that says that you can charge here for a quick charge we can charge at a rate of 4 amps for a period of 1 hour. Okay. Now if I charge at a rate of 4 amps for a period of 1 hour, that should charge the battery approximately halfway. So if it's fully discharged, it'll only half charge the battery. If the battery is half discharged, that 4 amps for 1 hour should fully recharge the battery. So that quick charge of 4 amps for 1 hour indicates that the 2 amp rate on my charger is fine. So it means that I can charge it halfway between a standard charge rate and a quick charge, and it indicates that I can charge that battery no problem at all using that battery charger that I just looked at. Now I have here a second charger. Okay, I have it plugged into a little adapter, but this is my Battery Tender Junior 800 battery charger, and I can read on this that it's for a 12 volt battery, and it says 800 mAh. So the 800 mAh is 800 milliamps. So it charges at a rate of 800 milliamps, and 800 milliamps is 0.8 amps. Okay, so this charger charges at the standard rate of 0.8 amps. So this is the charger that ideally I should be using to charge this battery. Okay, so that's what you should be looking for when you go looking for a charger to charge your battery. You want to charge it at a rate that's suggested as the standard charge, so 0.8 amps. So this is the ideal charger. So that's how you read the charging information on the battery. Let's look at this second battery here, okay, this smaller battery, and we can see that it too has, we can do the readings on this straight away. It says that it's a 12V, which is a 12 volt battery. So it's going to have a voltage of about between 12.6 and 13.1 volts when it's fully charged. It has a battery capacity of 4 Ah, which is 4 amp hours. So it's half the capacity of this particular battery here, this bigger one. And it has a 50A CCA. So that indicates that it has a 50 amp cold crank amp output. So it should be able to supply 50 amps for a period of 30 seconds at a temperature of minus 18 degrees Celsius before the voltage drops below 7 volts. Now we can see here that it says that it's a super gel battery. So this is a gel battery, so the electrolyte is essentially, I think that means that it's a gel inside. So it's a sort of a semi-liquid, and the VRLA battery, that indicates, VRLA indicates that it is a valve regulated lead acid battery. So let's write that down. So it's a VRLA battery. So that's a valve regulated lead acid battery. This is important information because what this indicates is a valve regulated lead acid battery, or a valve regulated battery, indicates that there will be a little that it's actually a sealed battery. So these two batteries, you can see that there is no way I can turn this upside down and nothing should come out. That's in theory with a sealed battery. They're quite safe. So you can turn this upside down and the acid, if there is some acid in it, it should not come pouring out. On the older type batteries, if you tip them up, there was a good chance that the acid could escape from the battery. So these are quite useful for motorcycles, because if you drop your motorcycle, your battery is going to end up on its side, or it's going to be flipped all over. And if it's a sealed battery, that acid is not going to escape, and it's not going to destroy the insides of your motorcycle or any of the metal pieces that are in the motorcycle. It also means that when you're charging or discharging the battery, the gases that are emitted through the chemical processes are they're semi-trapped inside the sealed battery. And it means that instead of the hydrogen and oxygen escaping into the atmosphere, they tend to be circulated inside the battery, inside the sealed battery, and they recombine into other chemical compounds. If the hydrogen and the oxygen are allowed to escape, as it was in the old traditional batteries, then the battery would suffer as a result. Essentially, you would have a loss of water over time in the battery, and it would not function as well, and it would have to be topped up. With these sealed batteries, you shouldn't have to top them up with water. The gases shouldn't really be escaping, and they're much safer. Now, the valve regulated indicates, let's get rid of it. The valve regulated means that there is a little valve. So let me see, can I actually get this open? Should be able to. I had it open here. Yep. Get this lid off. So this lid should not really be coming off. You shouldn't take the lid off these batteries, but I've taken off earlier just to show you. It's held on with a little bit of super glue, which I'll super glue it back on. This is a brand new battery, so I don't want to destroy it. There's actually, what can happen is if you overcharge a battery, if you charged it at too high of a rate, or if you kept charging it after it was fully charged, then it can cause problems, because it can cause the electrolyte to produce gas, mainly hydrogen and oxygen, which would build up in the battery, and if too much of those gases build up too quickly, they will damage the battery, and they will cause the casing to expand and possibly even burst. Either way, they could ruin the battery. So what it has is here is a little valve. There's a little valve here. So if the pressure gets too great with the gases, then they can escape through this little valve. So it's a little escape valve. So generally the gases are contained in the battery, but if the pressure is too much, they can escape through this little valve, and that's that little valve just there. Sometimes when you're charging the battery, if you're charging it at too high a rate, you will hear a little hissing sound, which indicates that the gases are escaping through that little valve. And then the other thing we can read here is the PB. So PB, if you see PB anywhere on a battery, also it says lead, then that indicates that it's a lead acid battery. Okay. This one here, you can see that, yeah, it says PB here. So that indicates that this is a lead acid battery because it has lead in it. You just let it fully discharge once or twice. There's a good chance that you actually either ruin the battery or that you end up in a situation where the battery just never performs as well. It doesn't hold as much charge, it doesn't generate as much cold cranking amps anymore. So that these variables that we see here, these ratings, they deteriorate over time. Now, the other thing that we can read from the battery capacity is actually the power of the battery. So let's just put that to the slide. So we know that this battery, this bigger one, is 8 amp hours. Okay, so we know also that the power is equal to voltage by current. So it's equal to, let's say, 12 volts by 8 amps, 8 amp hours. That indicates that the total power output from this battery is what? 90, 80, 96 watt hours.